Hi everyone, welcome to today's lesson. We are going to continue talking about the quadratic formula. So this is technically day 2. And the two objectives that we're going to hit today is what is a discriminant and how can it tell me how many answers a quadratic should have. And the second one, after I know how many answers it should have, then I'm going to go ahead and solve it using the quadratic formula. All right, so first off, if we are talking about a quadratic, and I'm going to draw a graph so we can have a visual of this. So I'm going to draw a parabola here. Remember, a quadratic function can cross our x-axis. That's where our solutions are. So this line, it can cross twice, like it is right now, just once, or it could not cross at all. So it could have two solutions, one solution, or no solutions. Okay, so let's figure out how we can determine how many solutions it has, if it has 2, 1, or 0. And it deals with the quadratic formula. We call this part the discriminant. So the discriminant is what is underneath the radical or underneath the square root. And that is what is used to tell us how many solutions. And so I'm going to kind of relate this back to things that you already know. So if I have the square root of 36, you're looking for two numbers that multiply together to get 36. There are two of them, 6 and negative 6, because 6 times 6 is 36 and negative 6 times negative 6 is 36. So when there is a positive number underneath the square root, we are going to have two answers, a positive and a negative of that answer. If I would have a negative underneath that square root, I have no solutions. It's not possible to square root a negative because even if I put 6 times 6 is 36, not negative 36, and negative 6 times negative 6 is also 36. So there is no possible answer on that one. So there are no solutions. And the last one, if I have the square root of 0, there's a 0 underneath that. If I square rooted that, I would only get one answer. I don't have a positive and a negative 0, so there is only one solution. So depending on what is underneath that square root, it's going to tell us how many answers there are. Okay, so let's kind of look at some of these. Now, before I go on the last lesson, so yesterday's lesson, we left our answers like this. This was actually one of our homework problems, and we left it like that because there was no perfect square for 17. So I'm going to show you how we can get an estimate of this answer, because really the square root of 17 is irrational, meaning it goes on forever and it doesn't repeat. So our two answers we get here are going to be irrational, but we're going to get a good estimation of them. Okay, so when the square root is not a perfect square, we still break it up into the two problems. 5 plus the square root of 17 over 2, and 5 minus the square root of 17 over 2. Okay, now this is where you're going to need your calculator. And if you type it all in at once, you will probably make a mistake. So I had my students kind of do this in two parts. First, I had them do 5 plus the square root of 17 in their calculator. And if you don't know how to put a square root for most TI-83s, you have to hit the second button and then the x squared, which is right next to the 7. And then you would type in 17. So if you hit 5 plus the square root of 17, you would get about 9.123, and it kind of goes on forever. And then do not clear it. We're just going to divide it by 2, which would be approximately 4.56. Again, it goes on forever and it doesn't repeat. It's irrational, but it's an approximation, so I should probably do a squiggly line here versus an equal, so approximately 4.56. All right, let's do the same thing for minus. We're going to do 5 minus the square root of 17. Hit enter. Gives us 0.87689. Again, don't clear your calculator and just hit divide by 2. And that would give us approximately, if I rounded it to the nearest hundredth, 0.44. So those would be our two estimations. Again, we're really close, but not exact. All right, so let's kind of put everything together now. So remember our steps. Step one was to set equal to 0. This one's check. Step two is to put in the quadratic formula, or plug in or substitute in here. So again, our formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's substitute in, and sometimes it's easier if we find all three values first. So find a, b, and c. So a is to remember the term in front of the x squared, so 1. B is in front of the x, so negative 3, and c is our constant all by itself, negative 10. Okay, so let's substitute in here. The opposite of b would it be 3 here, plus or minus the square root of b squared, so negative 3 times negative 3 is positive 9. Be careful with that and don't accidentally put negative 9. And then out to the side, I like to do this in one step, the minus 4ac. So I have a negative 4, that will always be there, times our a, times our c. So let's do negative 4, our a was 1, our c was negative 10, and if I multiply all that together, I have a negative times a negative gives us a positive 40. So when you go to put that underneath the radical, we're not going to put minus 40 because it turned to a positive. And then all over 2a, a was 1, so 2 times 1, which is 2. Okay, step 3 is to simplify, so to clean all of this up. So let's clean up the radical first. We're going to do 3 plus or minus the square root of 49 all over 2. All right, once you have one number, this is going to tell you how many solutions we have. So here we have what we call, again, the discriminant. Based upon what it is, it tells us how many solutions we have. It is positive. Positive means that we are going to have 2 solutions. All right, so let's go ahead and find those 2 solutions. We're going to square root 49. That gives us 7. And once we have that all cleaned up, here is where we split into our 2 answers. We do one that has a plus and one that is a minus. All right, so 3 plus 7 gives us 10 over 2. So one answer is 5. 3 minus 7 gives us negative 4 over 2, which is negative 2. So our 2 answers here are 5 and negative 2. All right, let's try another example. This one's a little bit different because one side is not equal to 0. So remember your steps. Step 1 is set equal to 0. So we need to make this right side 0. I'm going to do that by adding 9 to the other side. Remember, we want the left side to be in standard form. So highest exponent to lowest exponent. All right, step 2, we're going to plug in to the formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And out to the side, I am going to first identify my a, my b, and my c. So my a is in front of my x squared, which is 1. My b is in front of my x, which is negative 6. And my c is my constant, which is 9. Okay, so let's start plugging in now that we know all our parts. Negative b, opposite of b, so this would turn into a positive 6 since it was a negative 6, plus or minus the square root. B squared, negative 6 times negative 6 is positive 36. All right, here's where I like to do work out to the side. We have negative 4ac, so negative 4, our a was 1, and our c was 9. So negative 4 times 1 times 9, that gives us negative 36. So I'm going to put in a minus 36 there. Times 2a, a is 1, so 2 times 1 is 2. And step 3 is the cleanup process, so simplify. All right, so first thing we need to do is clean up underneath our square root. If we do 36 minus 36, that gives us 0. And if you remember on the last two, or the three slides ago, we said if our discriminant was 0, we were going to have one solution. And I'll show you why we only end up having one solution. It'll make sense when you see this. Okay, so I know that I am going to, because that is 0, I am going to have one solution. So now let's find that one solution. We're going to square root 0, which I only have one option, is 0. So I have 6 plus or minus 0 over 2. And now here, when I split it into the two problems, I'm going to have 6 plus 0 over 2 versus 6 minus 0 over 2. Because that was 0, 6 plus 0 and 6 minus 0 are going to be the same, and it only happens when it's 0. We will get the same answer, which that one answer is x equals 3. All right, let's try one last example here so we can kind of see all 3 options. So we saw one that had 2 solutions. We saw one that had 1 solution. Now we're going to see one that has no solutions. Okay, so again, follow your steps. Step one is to set equal to 0. So we're going to put the right side equal to 0. Got to get rid of that negative 11 by adding it. And write this in standard form, x squared minus 6x plus 11. Step 2 is to plug in our quadratic equation. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You will not have to memorize that. You will be given that on the test. You just have to know how to substitute in and how to use it. All right, so let's first pull out our letters here, a, b, and c. A is in front of x squared, so 1. B is in front of the x term, so negative 6. And c is our constant, so 11. So for negative b, I'm going to put in positive 6. For b squared, negative 6 times negative 6 is 36. And then here's where I'm going to do some work out to the side for negative 4ac. We have negative 4 times a, which is 1, times c, which is 11. That ends up becoming negative 44. And then all over 2a, so 2 times 1, which is 2. Okay, we always clean up underneath the radical there first. So 6 plus or minus the square root. That would give us a negative 8 over 2. Okay, so let's look at our discriminant. Our discriminant here is a negative. When it's a negative, we are going to have no solutions. And the reason being is that we can't square root a negative. It's just not possible for right now. In Algebra 2, I believe you'll start talking about imaginary solutions, but there are no real solutions. So we're going to say no solution for now. All right. We've got the last 2 left. We'll do one more together, and then you can try one on your own. You can pause. If you want to pause right now, go ahead. Feel free to do that. We're going to keep following our steps. So step 1 is to set equal to 0. I always want my x squared term to be positive, so I'm going to move everything else to the other side. So I'm going to make the right side 0. So it's going to become 5x squared minus 2x minus 8 when I move it to the other side. My a is going to be 5, my b is going to be negative 2, and my c is going to be negative 8. Quadratic formula again, negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so start with negative b. Our b is negative 2, so we will plug in positive 2. B squared, negative 2 times negative 2, positive 4. And we're going to do a little work out to the side for negative 4ac. So negative 4, our a was 5, and our c was negative 8. That would give us negative 20 times negative 8, which is positive 160. Since it's positive, I need to put a plus there. And last, all over 2a. A was 5, so 2 times 5 is 10. Okay, we're going to clean this up. We always clean up the radical first. So 2 plus or minus the square root of 164 all over 10. So our discriminant was 164. Positive, remember, positive equals 2 solutions. Okay, so let's go ahead and find those solutions.